Aloha, Richard Halverson here. This is ITS128, and we are at the end of getting to the end of chapter 7 here. And so today I'd like to cover the rest of up to the quiz, to the last quiz at least, comparing list comprehensions, which means creating a list from an expression, and then list methods. And so let me share my screen here. And I'm going to share this one. All right, so here we are. And so I've just opened up Pearson. And so over on the left here, I'm going to click on Table of Contents. Just let's say I'm coming in from a different week. Let's say I've been busy for a couple weeks and I need to come back and do some old stuff here. And so we're in lists. And the last video covered traversing elements in a for loop, which was, and there was a quiz at the end of that. And so we're going to do comparing. There's a quiz at the end of this list methods. So we're going to start today with comparing lists section. And so on the right here, I've got the quiz questions for the next quiz, which is 7.2.9, list methods. All right, so the first question is, given that A refers to a list, write the necessary code to reverse the elements of the list. Okay, so how do we reverse a list? If the list is 1, 2, 3, 4, 5, how do we make it 5, 4, 3, 2, 1? All right, that's the first question. Second question is, given a list named A list, write an expression that removes the last element of A list. So how do you chop off the last? So if the list is 1, 2, 3, 4, 5, how do you make it 1, 2, 3, 4 without the 5? Third question. Given a variable A list that refers to a list, remove the list's last element and associate that value with a variable k. So it's the same as this, except for that last value, we're going to capture it and set k equal to that last value. So if the list is 1, 2, 3, 4, 5, if A list is 1, 2, 3, 4, 5, then after this is over, A list is going to be 1, 2, 3, 4, and K is going to equal 5. All right, what's the fourth question? Given a list called playlist, write a statement that sorts it. Okay, so we got to sort playlist. Question 5. Reverse the list associated with, okay, so we have a list called words, and we're going to reverse it. Sounds an awful lot like this one. I don't see a difference, actually. All right, question 6. Given the lists list1, LST1 and LST2, create a new sorted list called new list. Create a new sorted list called new list consisting of all the elements of list 1 that also appear in list 2. So if list 1 looks like this, and list 2 looks like this, then the new list will look like this. I guess I'm stuck. Hold on a second. Let me make a little adjustment here. There, how's that? So if this is list 1, and list 2 is this 1, 2, 4, then the new list will be 2, 2, 4. So we see what it does is it first checks to see if 4 is in this list. Let me just do this. It first checks to see if 4 is in this list. It is. Wait a second. Is that the way we do it here? Yeah, I guess that's the way we would do it. Oh, it's got to be sorted. That's why. A sorted list. It says, don't forget to sort the new list. Okay, so it first checks to see if this is in there, and it is. Then it checks to see if this is in there, and it's not. Then it checks to see if 2 is in there, and it is. Then it checks to see if 6 is in there, and it's not. And then it checks to see if 2 is in there again, and it is. So it's going to be actually 4, 2, 2. It's going to be 4, 2, 2. And then once it's sorted, it's going to sort to be 2, 2, 4. Okay, so that's question 6. Question 7 is we have the following sequence. Each number except for 2. Oh, is this? Okay, this is Fibonacci sequence. Okay, so except for the first 2. Okay, so we start with 0 and 1, and then the next number is the sum of the last 2. So this number this number is going to be 1 plus 0, which is 1. This number is going to be 1 plus 1, which is 2. This number is going to be 2 plus 1, which is 3. This number is going to be 3 plus 2, which is 5. This number is going to be 5 plus 3, which is 8. This number is going to be 8 plus 5. Okay, so each number is the sum of the previous 2 numbers. It's called the Fibonacci sequence. So what we're supposed to do is, given an integer n, write a program that generates Fibonacci numbers, all the Fibonacci numbers that are less than or equal to n. So basically, whatever n is, we just start computing these Fibonacci numbers until we reach n. If we go over n, we don't include that one that we went over. If we hit n, we can include that one, and then we quit. So for example, if n is equal to 6, it's going to be all these numbers, because those are all the numbers less than 6. If n is 1, then it's going to include all these numbers, because because these are all the numbers that are less than or equal to 1. And that new list, we're going to name it fib. All right, the last question here is, given lists list 1 and list 2, they're the same length. Create a new list consisting of the first element of list 1, followed by the first element of list 2, followed by the second element of list 1, followed by the second element of list 2, and so on. So if we have a list 1 is 1, 2, 3, and we have another list 2 is 4, 5, 6, then it's going to be 1, 4, 2, 5, 3, 6, and you should have seen 1, 4, 2, 5, 3, 6. And this new list, it's going to be called list 3. All right. So let's go through the textbook, the chapters, the sections of the chapter, to find all the places where we find where we can find the answers to these questions. All right, so we're talking about comparing lists now, and we're comparing entire lists, not just elements of a list, but the entire list. And we use the same looking operators: greater than, or equal to, less than, whatever, all these same operators. And basically, it does like an alphabetical ordering for these operators. It's just like when you have strings and you're using these operators to compare if 2 strings are equal or greater than or less than, you do an alphabetical ordering. Well, it's the same kind of thing with this, except for you can think of each element of the list as a character in a string. So when we have, this is 2 lists, and if they're not equal, they're you know, they are equal. List 2 is greater than list 1 because we start with the first element, and red is higher up in the alphabet than green. You know, red alphabetically comes later or higher than green, so that's why list 2 is greater than or equal to list 1. List 2 is greater than list 1, and list 2 is list 2 less than or equal to list 1? No, that's false. Same with this. Alrighty, what's next? I'm gonna switch my fancy monitor over here back to the way it was. All right. List comprehensions. All right, so so this is a list comprehension. We have a list, and how do we define the list? Well, we comprehensively define it like this. It's all x's in here. So you know, x in the range 5, that'd be 0, 1, 2, 3, and 4. All the x's defined by this. And here we go. All the x's, for all the x's in list 1, for all those x's, multiply them by 0.5. In other words, you know, divide them by 2, or multiply them by 0.5, and that makes up our list. So, you know, this is, so half of, you know, multiplying each of these elements by 0.5, you get this. So here's another way of expressing a list. It's all the x's generated by this for statement, where those all the x's, excuse me, where x is less than 1.5. So it goes through all these x's, gets all the x's in here, and if that x is less than 1.5, then it is included in the list. So, oh, this is list 2. Oops. List 2, which is this list, which we just created here. This is list 2. So it's all of the ones that are less than 1.5, and that would be these first 3. That's why we have this here. All right. Okay, what's next? List methods. Okay, these are a bunch of nice list methods here. And the list class, this is a list class. It's a class, so that means you use these methods by putting the list dot append x, list dot count of x, list dot extend. Okay, so append just means, okay, you have this list like this, and you're just appending 19 onto the list. You append this append it to the end, and so the new list, the same list, it's list 1 still yet, but now it looks like this. It's got a 19 there at the end. Here we're counting up the number of 4s in this list. Well, there's a 4 here and a 4 here, so that would be 2 4s. And sure enough, that's what the answer is. And let's say we got a list, another list called list 2, and let's say it's this. And we want to append that list onto list 1. Well, list 1 right now is equal to this. So if we I'm sorry, extend, it's like append, except for it's a list. You're extending, you append, when you append a list, you're extending the list, I guess. So we extend onto this list these 2 elements, and we end up with the first list and then the 2 extended there. This returns the item, the element at position number 4. So this is this list 1. So position number 4 would be 0, 1, 2, 2, 3, 4. 2. Why is it a 2? Position number 4. Oh, I'm sorry. I'm sorry. Wrong language. We want to find the first 4. We want to find the index of 4. This is not returning the index at the 4th position. This is locate for me the value or the index of this value. And it might be, I don't know what happens when it's not there. Let me I'm going to try, let me try this out. Online Python interpreter. Online Python interpreter. Here's a nice online Python interpreter. Okay. And I'm gonna okay, so list looks like this. I'm gonna say list. I'm gonna say, I just put it up after this. List 1 equals that. Okay. And then I'm gonna say this. Does this work? Does that work? No, it doesn't. I gotta print it. Print this. All right, it printed 2 because that's the index of the first 4. So let's make sure I do this. Find the 1. Find the 1. That's at 3. 0, 1, 2, 3. Find the 19. 6. 0, 1, 2, 3, 4, 5, 6. All right. Find the 10. There is no 10. What happens when I try to find a 10? It returns, oh, error. All right, that's good to know. All right, so so it's got to be in there. Okay, and this inserts 1 and 25. Oh, insert 25 at the index of 1. So index 1. Okay, so this is index 1, and we're going to insert 25 there. And I guess what we do is we push everything else up. We insert 25 in between here, so 25 goes there, and then all this stuff gets pushed up, pushed to the right by 1. All right, so that's a description of this here. What is, oh, no, here's some new instructions. All right, these we have these instructions, these methods here: insert, pop, remove, reverse, and sort. Let's see. We're going to be using. Okay, and so inserting, we want to insert. What do we do here? These are append and count and extend and index and insert. We're looking at insert again, I guess. No, we're not. Okay. So popping means you want to pop. We pop the second index, which is this number. So it's the opposite of this kind of thing. Here we're inserting 25 at the first element. Here we're popping the second element, 0, 1, 2. So we pop that out, and we actually remove it. So that's why we don't see it over here anymore. Here we're just popping the last element. We're popping this one. And here, this is what it looks like after we popped it. And so, and here we are removing item 32, removing this number, and this reverses it. So 2 all the way up to 99, this is 99 down to 2, and this sorts it. Okay, now let's I think we know enough now to go back to these questions over here. We need to reverse. Okay, so reversing is this one. And we need to remove the last element of the list. Ooh, that looks like this one. This one removes the last element of the list. So pop with no argument. Given a variable alias refers to remove the list last element and associate with. Okay, so we just say k equals this. Okay, this one would be given the playlist. Sort the playlist. Just use this playlist.sort, just like we do list1.sort. Oh, this is clever. We can do that. This makes it descending. This makes it ascending. All right, reverse equals true. So, but we aren't going to be reversing in this one. Okay, this one is reverse the list. Well, that's just, that's the same as up here. Yeah. And then given lists L1 and L lists list one. Well, okay, so here we're going to loop through, and what we'll do is we will, for each one of these, we're going to loop through these to see if it's in there. And if it is, we're going to attach it to, we're going to append it to this new list. And for this one, Fibonacci numbers, we're going to be indexing again, and we're going to reference the previous two, or maybe we'll reference the first one and the one just before it, and we'll add those two together, and we'll append that onto the end. And this is a simple thing that we do when we're doing like a merge sort. We're just going to alternate, this one, and then this one, and this one, and then this one, and then this one, and this one. All right, so let's. So what's next? Are we at the quiz? Yes, we are. Okay, let's 8 questions. Let's 8 questions. Let's start with the first one here. Given that a list A refers to a list, write the necessary code A dot reverse. That's I'm gonna go back. I'm gonna go back here, and I'm gonna make some notes. I'm gonna try to put the answers right here. I would say that's A dot reverse. I would say this one is A list pop. I would say this one is K equals A list pop. I would say this one says this is playlist sort. And I would say this is words reverse. It's words. And I would say this one is new list equals nothing for can we use any, doesn't limit the variables. Okay, for L1 in LST1, for every L1 in LST1, I'm going to do for every element in list 1, for I'm going to call this E1, element 1 in list 1, for element 2 in list 2, if E1 equals E2, then new list append E1. Something like that. Let's see. Well, this is question number 6. Yeah, something like that. Wait a minute now. Oh, okay, right. Another thing we can do is we can use in. Okay, well, anyway, this works. But it turns out we can also use the in operator. Yeah, we can use the in operator. We can do well, I'm just going to leave it at this and try that. And then 7 is Fibonacci. Okay. That would be, first of all, let's initialize the Fibonacci. Fib equals, we can initialize it at 0, 1, because those are the first two numbers. And then we can do 4, oh, we're supposed to go up to n. So, okay, so Fib 2, 4, while, okay, length of Fib, okay, the length of Fibonacci is going to be 2. The length of Fibonacci right now, Fib is 2. So while Fib, len of Fib minus 1, okay, this right now is referring to, the length of Fib is 2, so the index is 1. So this is referring to this number, while that number plus Fib, the length of Fib minus 2, okay, that's this number, because Fib is 2, so this is Fib, this is length of Fib minus 1, and this is length of Fib minus 2. So it's the 0th one. While this value is less than or equal to n, then we want to append Fib, append this value here. Copy, paste. Okay, I think it's something like that. All right, what's the next one? Oh, now this is this alternating. So let's initialize list 3 to equal nothing. And we're going to go for the two lists of the same length. So we can just use one of them to do for I in range. So it's because we want to do it in order of list 1. For that, we want list 3. I want to append to it list 1 of I, and then list 3 append list 2 of I. So something like that. All right. Okay. The last thing I wanted to point out, this thing here. So here we start with E1. This is question 6. Let me just go to question 6 here. So this works. That should work. Because this loops through all of the elements of list 2 and checks to see if this one that we're looking at first is equal to any of these elements. So that looks, does this work? Yeah, this works. Okay, see, this is a different solution here. This uses the in operator. And so the in operator for lists is just like the in operator for strings. What this does is this looks to see if I is in this list at all, which is exactly what we need to know here. For each one of these, we want to see if each one of them is in this entire list, which is this entire list. So 4 is, 3 is not, 2 is, 6 is not, and 2 is, you see. So here we're just using this if I is in this list. And this thing here, when this thing is evaluated, when this is evaluated, it will loop through all of the elements of list 2 to see if I is one of them. Whereas in my solution, I manually went through each element of the list. I look at each element at a time and I compare each element. See, this just says, I got this element here, look in here and see if it's in there. See if it's in there. If it is in there, then do this, which is to append the number. All right, so for the rest of these, you should be able just to try these out, and we can try some, let's do some errors. Let's put some errors in here. Let's try number 7. You know, what happens if I do this? So it should be less than or equal to, because we actually want to, in this first case, if n is 1, then we need to include all these 3 elements, and not, and if we're only looking for less than 1, it's not gonna include those that are equal to 1. So let's see what this says when we make this error. And it says, okay, so here's the first one. Oh, by the way, it says correct solutions that use 2. This is the 2, I guess. Tend to also use if. Oh, solutions of your approach don't usually use a less than sign. Look at that, they split this infinitive here. It should be also to use. Okay, so this doesn't look like very good advice, but this does. And what they're saying is that it doesn't usually use this. That'd be this here. And as we know, it should be less than or equal to. But so what else does it say here? Okay, so the first thing it did is it tried n equals 21. And then it looked and it started computing. And it should have computed all the way up to 8 plus 13 is 21. And it should include that. But in our solution, we did not include the 21. So it says fib does not contain the correct value. Same with this one. It actually tried this when n is equal to 1. And that's interesting that we got the first one there. Oh, that's because that's how it's initialized. Never mind, we initialized it that way, right? And it didn't get the next one following. This one didn't get the 2. This one didn't get the 5. Okay, so in this time I tested 4 things. So if we go back and fix it, then we get the right answer. How did it do it? Oh, it did an exchange. So it actually keeps track. It actually kept track of this last one and the second to the last one. And then it's an interesting solution there. All right, so anyway, I think I have given you. Oops, let me stop sharing here. I think I've given you enough ammo here to finish this last quiz, and so after this, I will start working on the projects. So thanks for watching.